Okay, so it is Sunday afternoon. The chamber is down in the 10 to the minus 7 millibar range, so it's pumped out well overnight. We are ready to begin evaporating. So the first thing that we need to do is to turn on the water cooling. So that is this valve down here. I'm going to turn this valve to the on position. This is important for the evaporator to turn on. In fact, it won't actually turn on until the water cooling is on. So now I'm going to turn on the power for the evaporator. That is here. Now the power is on. You can see the light is red. This is the main knob right here that we will use to adjust the current through the tungsten boat during the deposition. This object over here is the crystal monitor. This is what we use to determine the thickness of the film we are evaporating. So this number over here is the deposition rate in angstroms per second. So remember that 1 angstrom is 0.1 nanometers, and over here you see the total thickness of the deposited film in units of kiloangstroms. So 1,000 angstroms, or 1 kiloangstrom, is equal to 100 nanometers. One other slightly complicating factor here is that the parameters for the film have been entered in such that the rates and thicknesses you see are actually 1/5 of the actual rate and thickness. So in fact, over here on this number, 5,000 angstroms or 5 kiloangstroms is actually equal to 100 nanometers. So we will deposit a 70 nanometer film at about 2 angstroms per second. So the total thickness will be 3.5 kiloangstroms on this monitor when we are done. So that's the crystal monitor. We'll come back to it. Here again is the pressure gauge. We'll keep an eye on this. Here's the roughing pump, and of course the turbo pump. I have also written down in the logbook that we will start pumping at about 1:30 p.m. and I've recorded the starting pressure of 0.87 times 10 to the minus 6 torr. Alright, so the crystal monitor has stabilized. The rate will fluctuate a little bit when the water turns on, but it is now stabilized. So I will turn on the current. So I'm going to turn this knob clockwise until I see the current reading jump here. So there we go. There's current starting to flow through the boat. I'm going to wait about 1 minute. 1 minute for every 10 amps. So we're using the 300 amp range here, so we're using the bottom scale. So right now there are about 60 amps flowing through the boat. I'll increase it by about 10 amps every minute or so. Usually I use the timer on the crystal monitor to keep track. We'll see that the pressure starts to increase as we turn up the current. Eventually, we will be able to see the boat through this window here, and of course the sample shutter is still closed. We will wait until we have an acceptable rate to open the shutter. So I'm going to increase the current by about 10 more amps here. There we go. So the pressure is starting to increase. That's because the boat itself is starting to get hot and it's driving off water inside the chamber. Typically the aluminum will melt at 110 amps. So once we get there, we'll wait for a little bit for the aluminum to melt. Pressure is rising a little bit. This is all fine. It's important to make sure the pressure is less than 5-6 when you're depositing aluminum. In case you forget what's going on, remember that there are directions posted up here on the wall. Bring the current up to about 100 amps now. Pressure is slowly coming up, but it looks okay. You can start to see a little something in there. The boat is glowing now, so the camera isn't focusing on this, but if you look through there at this glowing piece, you can see the glowing boat and then also the aluminum pellets. In fact, I'm going to go turn off the lights here. Alright, let's bring this up to 110. So we should see that the aluminum will start to melt. You can sort of see the pellet on there. It's not really focusing. Pressure is 1.9 by -6. I'm going to take a look here. So the small pellet has melted. You can see now the larger pellet. Oh, the larger pellet just melted. You can see how the boat gets darker and that black spot in the middle is spreading out. Good. So you see the pressure is dropping now, and there's now a slow rate. We're coating the chamber a little bit with aluminum. The pressure is dropping because the aluminum is reacting with water vapor in the chamber. So typically we do a small buffer layer. So I'm going to increase the current to about 120 until I get a rate of about 0.1 to 0.3 angstroms per second. Then I'll do this for about one nanometer and then increase the rate to 10 angstroms per second on this crystal monitor, which is actually 2 angstroms per second in real life. Okay, it's nicely melting. You can see kind of a large spot as the aluminum is coming together. So I'm going to zero the crystal monitor and open the shutter here. And now we're depositing our buffer layer. I'm going to actually increase the current just a hair. So the rate can be 0.1 to 0.3 angstroms per second. And again, we'll do this for 1 nanometer, which is 50 angstroms or 0.05 kiloangstroms on this monitor. So I'm going to write down now that our pressure is about 1.9 times 2.2 times 10 to the minus 6 and a current of about 130 amps. When we're doing the buffer layer, we can go up to 8.3 angstroms per second. I'm going to increase the current just a hair. There's the boat. Metal looks good. It's nicely coating the boat right now. So I should add that following this sort of 1 minute per 10 amps rule empirically is pretty important for this evaporator to work well. So I'd recommend following that unless you have a very good reason not to. I'm going to go turn the light back on. So the pressure in the evaporator is starting to fall. Again, that's because aluminum is coating the side of the chamber and it's helping to react with any excess water vapor inside the chamber. Okay, so we have 1 angstrom of 1 nanometer rather of aluminum deposited at a very slow rate. This is the buffer. Now I'm going to increase the current to about 10 amps to 145. The rate will come up. We want to be at about 10 angstroms per second on this monitor, which is 2 angstroms per second in real life. Again, we're going to go to 3.5 kilo angstroms in total, or 75 nanometers. Sorry, 70 nanometers. 3.5 kilo angstroms is 70 nanometers. Okay, I'm going to increase this a little bit more. Eventually we'll be at 150 or 160 amps for this fast rate. It can take some time for the rate to stabilize. The shutter, of course, is still open. Pressure is increasing. There's our boat. It's glowing much brighter now. Still looks good. It is coming up. Now it often will spike, so we'll keep an eye on this and possibly turn the current down if we need. You could go as high as 12 angstroms per second on the monitor here. I'm going to turn it down just a hair. You see it responds. Alright, so we're at 150 amps, about 10 angstroms per second. The pressure is 3.4 times 10 to the minus 6. So I'll write all this down. And we're going to continue until we get to 3.5 kilo angstroms on this monitor. Again, that's 70 nanometers actual thickness on the surface. Eventually we'll start have to increasing the current. You want to increase it as little as possible. When you increase the current, the pressure will come up. Usually we say that you need to be below 5 times 10 to the minus 6 for aluminum to work well. Okay, so the pressure is climbing because I've had to increase the current. We're closing in on our target thickness here. Okay, and we're going to close the shutter. Okay. Pressure went up to 4.6, that's okay. So I'm going to slowly start decreasing the current. So I'll ramp it down over about a minute. Okay, once the current is off, I'll turn off the power here. Now I'm going to let the system cool off with the water cooling for about 5 minutes here. So usually when the timer gets to 18 minutes, I'll shut off the water and then we'll start venting the system.